Okay, now I have record it and I will continue the presentation in this evening meeting. In this meeting, we will talk about two things. We will talk about integration technique for irrational function. And the second, we will talk about integration technique for rational function by partial fraction. So today, this evening, we will talk about two things: irrational function and partial fraction. If you have uh, difficulties to hear me or something wrong in my during my presentation, don't be hesitate to interrupt me, and you can raise hand and say something about my presentation. Okay, let's we start the first technique in this evening. In something wrong with the symbol. Mhm. Okay. Can you see my slide? Please respond me.
Yes, sir.
Yes,
Okay,
sir.
thank you. This is the meeting 9, and this is uh, the first technique in this meeting. We will talk about irrational function. Still something happened. Wait a minute first. My my pen tablet is not working. I must fix it. Wait a minute, yeah. Well, yeah. In this rational function, we will talk about. Hmm. Sorry, yeah. Uh, there is some something wrong with my presentation. Yeah, please be patient. Still uh, fixing something. I'm s- I'm still fixing something. Can fix it. Uh, this is rational, the irrational function uh, in root of fx. Uh, and the x is a linear function. Uh, uh, this is a linear function ax plus b, where a and b are constant. And in this case, to solve the irrational function, the integral of uh, contains irrational in the integrand. Integrand, we use substitution to solve such that the integrand become rational. So this is the idea. We have here irrational. So we do substitution such that the integrand become rational. So this is the idea. And how to do that? Look at this example. We we solve it or we solve this problem by using the example. This is irrational because components in the function contains square root, and we try to to change this function become a rational function. How to do that? In this case, we have two components. The first component contain square root, and the second contains fourth root. Fourth root. Yeah, this is fourth root. And now we want to choose a substitution. U the smallest power. Yeah, we choose the smallest power. In this case, this is the smallest. Yeah, because uh, this uh, for root become 1/4 power of x plus 1. So this uh, is equal with the half. We choose this one. Yeah, we choose the smallest power as the substitution. So we have u is equal to x plus 1 power to 1/4. By using this substitution, we must change all of the components. This is must be uh, become by du, and also this is become variable of u. How to get it? Uh, we we make a rational. To make a rational, we make a, we take a power of 4 on both of the side. We have u power of 4 is equal to this is also x plus 1 uh, power of 1/4, and then power to 4. And we know that this is must be multiplied. So we have u 4 is equal to x plus 1. Uh, we need dx. Where is dx, or how to get dx? We differentiate both of this side, and in the left we will have 4 u power of 3, and in the right we will have dx. So dx can be replaced by, oh sorry, we must have here du. Yeah, du is equal to dx. So dx can be replaced by 4 u power of 3. Okay, next we must replace here, yeah, square root of x plus 1. And we can get it from here, yeah, from here. We take a square root for both of these equation, or for both of this side. We get it 4 and square root of them, and it means also for the 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 right x plus 1 x plus 1 1 over 1 over 2. Yeah, so square root of x plus 1, and this is multiplication of 4 and a half. So we have u square is equal to x plus 1 power to 1/2 or a half. So this is our substitution here, our substitution, and the x will be here, and the square root of x plus 1 must be u squared. So we so we replace uh, all of the integral here. We get in integral of dx become 4 u cube du divided by will be u squared, and the second will be u. Yes, so this is the substitution. So now we must solve this integral. Our integral become the integral of polynomials uh, fraction. Denominator and numerator are polynomials. So maybe we can simplify this one. We can pull out 4 or from integral, and also we can cancel out or cancel one u, maybe u. This is u square du, and divide by this is will be u plus 1, something like that. So we can cancel out u. So we have sorry, we have here this is will be 4 u square du divided by u plus 1. Okay, we have this result. So next we must divide u squared by u plus 1 uh, using the division. As we know, uh, uh, before, this is u plus 1 divide u square, and this is the multiplication by u. So we have u square plus u here, and subtract it. We have minus u, and then we must multiply by minus 1. So we have minus u minus 1. Then we subtract again. We have 1. So uh, the the result will be u square divided by u plus 1 will be the result u minus 1. Then we the remainder 1, and divide by the denominator u plus 1 denominator, ya. So uh, our integral become 4 integral of u minus 1 plus 1 u plus 1, ya, plus 1. Okay, this is the integral, and we look at that the last equation or last integral is it easier than before, so we can solve the integral easily. Yeah. Okay. Now we integrate them to get the result, and the result as follow. This is will be I uh, I write here. Then this is will be 4. The integral will be u integral by respect to u will be u square divided by 2, and this is will be minus u, and this is will be uh, logarithm of a natural logarithm of n, oh sorry, u plus 1, u plus 1. And maybe we must get 1c outside. And so we have multiplied by 4, we have 2u squared minus 4u and plus 4 uh, ln u plus 1 plus c. Okay, then substitute again, as we know before, u is x plus 1 power to 1 over 4. U square is u x plus 1, power to 1 over 2. So we have that solution should be in by x again. So will be 2. This is x plus 1 uh, power to 1 over 2 and minus 4. This is x plus 1 power to 1 over 4 and plus 4 natural logarithm of x plus 1 power to 1 over 4 plus 1, and then the last the constant of c. So we have this is our last result. Our last result. Okay, this is the solution of example 1 in this meeting. We solve about the irrational function. Right? Irrational function. Okay, yeah, should be we can write in this empty space here, but I have already write in this slide. So let we go to the second techniques in this evening. We talk about how to integrate by using this technique, partial fraction. And what is partial fraction and uh, how to do this technique? Okay, let's we talk about it. Uh, if in this statement say that if the integrand means that the function we want to integrate is a rational function, and rational function like this. This is numerator and this is denominator, where px and qx are polynomials. Polynomials, in bahasa we say that suku banyak in x, in variable x, with a degree of px, is less than uh, degree of kx. So we must make sure our technique must be applied in this condition. Yeah, degree of px is less than degree of kx. What happen if the degree of px might, for example, greater than degree of kx? If this case happen, so we must divide first. We must do uh, as we do in the last slide. Kx divide px. Uh, Sum that after we define, maybe we have uh, kx, kx, and we have the result maybe, and uh, we also have a reminder. In this case, we say sx. This is sx and divide by qx. So maybe we have this condition. Yeah. Okay. If we have this condition, the degree of px greater than or equal to degree of qx, so we must divide first. Okay. Then uh, if we already have a degree of px less than degree of qx, so we can go to the second, to the next procedure. Maybe we must do some partial fraction. What is some partial fraction? Sum of partial fraction means that px or qx will be right as uh, the sum of partial. So we uh, will write px and qx so follow. Yeah, and so on. Yeah, maybe we have more than one, more than two, three, or and so on. Uh, uh, how to get it? How to make partial fraction? We need to we must know the composition of qx to get it, to do the partial fraction. We must know the composition of qx. It means that we must we must get the factor of qx. There are two kind of factors. The least factors, jadi faktor terkecil yang dipunyai suku banyak itu uh, uh, first is linear factor, linear factors. Yeah, this is the common factor, and the second, maybe we have quadratic factors, quadratic quadratic factors. In this case, we have that they are must be defined positive or negative. Yeah, positive or negative. So qx must be decomposed or must be have the composition uh, linear factors and quadratic factors. So uh, we uh, we have four four possibilities, yeah, four possibilities uh, of the decomposition of QX. There are four possibilities, yeah. QX, we as we know in the previous, can be have linear factors, yeah, linears vector, or maybe they have quadratic factor, uh, quadratic factors, quadratic, uh, uh, quadratic. For linear factors, we have two case, non-repeating, non-repeating. They all of them are different, non-repeating. And, uh, the second is repeating. Also, for the quadratic, we also have the case of non-repeating, and the second we might be repeating, repeating. So uh, we have four possibilities, and we say these possibilities as case one, these possibilities as case two, and these possibilities as case three, and the last, this is case four. Next, we want to make it detailed about case one, case two, and case three, and also case four. Okay, case one. Case one, uh, say that uh, QX, QX consists of non-repeating linear factors. It means that uh, the factors of QX is different, of the difference. This is one factors, second factors, the first factor, second factors, and maybe we have n factors. All of them are linear. Yeah. This is uh, linear. Uh, all of them are linears. Yeah. Linears, linears, and they have different coefficients. So they are non-repeating linear vectors. Now, uh, for this case, if we have here QX have non-repeating linear vectors, so the theory, the the partial fraction of Px over Qx will be right like this. This is the partial fraction. Okay, we'll look at one by one. This denominator, the first denominators come from the first limiters. So this is also the second denominator comes from the second factors of QX. And this is also, yeah, yeah. So but the problem is we don't know about the nominator. Uh, in this case, nominator nominator must be constant. So uh, the factors are the denominator are linears, but the uh, in the numerator, sorry, numerator, not denominator, numerator must be must be constant. So this is constant, so constant, and also constant. And we must find what is the values of this numerator. So we next next effort is uh, uh, our next efforts are to find the value of this constant, and we will do it later, yeah, by using some. Uh, we uh, we describe or we present all of the case. Then after that we give example to explain by using numbers of each of cases. Okay, now let's we go to the case two. In case two, say that QX contains repeating linear factors. What 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 is repeating? Repeating means that the factors not only one, not comes out one, but more than one. This is, for example, A1 plus B1 might be comes out more than one. In this case, and maybe. So this is called as repeating linear factors. Yeah, maybe we combine by other non-repeating linear factors. Yeah, but our focus in this case, yeah, for this uh, factors. Yeah. Okay, so we say that these factors A1x and plus B1 is repeating n times, yeah, repeating n times. And now the others is a non-repeating linear factors. Okay, so to get the partial fraction of in this case, the partial fraction we have this pattern, this partial fraction. We have one, yeah, one, two, uh, three up to n. So we have n partial fraction. This one for a non repeating, yeah, non-repeating. For the repeating, we have that this is power of one, yeah, power of one. This is power of two over there, over here. So and so on, so on, so on. And this is minus one in this power. So totally we have this is in components, n components. So um, the denominator uh, increasing from 1, 2, 3 up to n. Yeah, up to n. And the constant, still constant. Same as case 1. So the numerator still constant. And of course, this is constant also. We make different symbol for the non-repeating become B1. For the repeating symbol, we make A1, A2 up to AN. Okay, uh, this is the case 2. Yeah, so you can look at that. The case 1, case 2, case 3, and case 4 depend on the factors of QX. So you must know the factor of QX because the partial fraction based on factors of QX. Okay, let's go to the case 3. Case 3. Uh, Case 3 said that if QX contains non-repeating definite quadratic factors. So this is quadratic factors, but we also know that not all of the quadratics uh, will be count. Yeah, so we must have a definite quadratic factors. What is definite quadratic factors? I will give you the example. Yeah, square minus one, x square minus one. Uh, for example, these factors, we have that this is can be divided into linear factors x minus 1 and this is x plus 1. And what happened for this one? X squared plus maybe 2x plus 3 maybe. Uh, in this case, we cannot, we cannot factor them become linear factors. So we cannot. Why? Because this is definite, 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 definite means that certain harus pasti pasti positif or pasti negatif, but this is not uh, non definite, non not defined, yeah, not defined. So to know quadratic function definite or not definite, we can use this determinant, yeah, determinant. Uh, sorry, not determinant, discriminant. Using these formulas, uh, square plus bx plus c, and the discriminant is b square minus 4ac. If b square minus 4ac uh, less than 0, so this is definite, definite. But if we have b square minus 4ac greater than or equal to 0, this is not definite. So this is how to classify not definite and definite. Okay, we check for this quadratic b square minus 4ac will be a will be 1 here, b will be 0, so 0 square minus 4 times 1 times c minus 1, yeah, minus 1 minus 1. So we have 4. 4 is greater than 0. So this quadratic must be not divided. And what about this one? This quadratic. This quadratic b square minus 4ac will be this is 2 square 4 minus 4 times 1 times 3. We have minus 4 minus 12 will be minus 8. So this is less than 0. So the this quadratic must be defined. And uh, if we have the QX contains definite quadratic factors, and might be more than one for here, for example. So we can express our PX and QX by using these formulas. Yeah. Uh, Quadratics, the factors of quadratics in this case, for example, we have 1, 2, up to 3 factors, yeah. Oh, sorry, n factors. So this is all of them n factors and n factors. So we also have partial fraction and components 1, 2, up to components. And each of the components have a denominator, the quadratic, the quadratic itself. This is the quadratic as we have in the vectors of qx, and a numerator of them uh, linears, linears. So case 3, yeah, and case 3 different from case 1 and case 2. In this case, this numerator will be linear. Yeah, all of them are linear. So, sorry, linear. So we must we must find it to this is yeah, of course, this case more difficult than case 2 and case 1. Okay. Uh, the last case uh, is case 4. In this case, we have the situation QX contains repeating definite quadratic factors. So this is our QX, and yeah, uh, because of because of the quadratic function, the quadratic factors of QX uh, can be long to write. So just sort, we just make the representation, the repeating of the definite quadratic factors in 3 times. And this is we combine with the non-repeating quadratic factors and also the linear vectors, one linear vectors. So we have that uh, quadratic terms 3 times, repeating in 3 times. This is one of quadratic non-repeating. definite quadratic vectors, and this is linear. So we have 3 plus 1 plus 1. We have five components, yeah, five components. Okay, this is the component 1, 2, and 3, yeah, 1, 2, and 3, where the uh, uh, denominator is quadratic, repeating definite quadratic factors, and them increasing from 1, 2, and 3. Yeah. So, and the four, the four factors is non-repeating quadratic factors. So the we have four components and plus the component from linear. Yeah, this is just for the example. Yeah, no, we we combine linear non uh, non-repeating linear factors, non-repeating definite quadratic factors, and we have repeating definite quadratic factors. So uh, the quadratic uh, have the quadratic definite factors in the denominators. So numerators must be uh, linears. So this is linears. This is also linears. This is also linears because their uh, denominators are definite quadratic factors. In the case, the denominators is linear, so the numerators will be constant. So, okay, we already discussed or we already have four case from the possibilities of the vectors of Qx. We have case 1 for the non-repeating linear factors, case 2 for repeating linear factors, and case 3 for the non-repeating definite quadratic factors, and the case 4 for the repeating definite quadratic factors. Yeah, after we know how to make a partial fraction from the four case, so after that we we will give you I will give you the brief steps for solving integral by partial fraction. So this is the steps for solving integral by partial fraction. First, make sure that a degree of px less than degree of qx. So you must make sure that degree of px here must be less than the degree of qx. And again, if you the another situation, a degree of px greater than or equal to degree of qx, you must divide it first. Okay, after you do the first step, next you must do the second step. What is the second step? Second step is decompose px. So you must uh, get the factors of qx. So you must uh, get the factors of qx, and the factors will uh, can be linear or can be quadratic, definite quadratic. Yeah. So after you get the decompose of qx, you can decide what case you will have. So after you get the composition of QX, you can decide what case you will have. You will have maybe case one, and case one means that all of the factors of QX non-repeating linear factors. And case two, case three, case four, case four. After you know what case you will have, so you you can uh, express uh, Px and Qx as a sum of partial fraction. Yeah, after you can express Px over Qx as a sum of partial fraction, then you must determine the value of partial fraction coefficient. So you must uh, find the value of A1, A2, maybe uh, B1, B2 as your symbol for the numerator, B2, and so on. You must, you can determine this value. After you know the value of A1, A2, B1, B2, and so on, depend on your expression in point three, so you can solve this this px as you have px. So in the beginning, qx, after you get the decomposition, it means that you get the partial. It means that you have a new form of px and divide qx. This is maybe your partial fraction here. So the integral become the integral partial fraction. Uh, you get the result. So this is the steps for solving integral by partial fraction. Okay, look at this example. We'll solve you one by one this example, one, two, and three. In this case, you have the integral of this is px. It means that we have one, the uh, denominator, so qx. We will have square minus one. Yeah, so this is uh, example number one, and this is number two. This is the px, py, no, yeah, because the variable in y. This is qy, qy, and so this is px, and this, then this is qx, qx. Uh, in number one, we know that the degree of px is zero, yeah, because constant means that we have the degree is zero. So degree of px will be zero. This is degree of qx will be two. You know that the degree of polynomial is the highest powers of polynomials. Yeah. So in this case, we have the highest powers is two. Degree of qx is two. So in this case, we already have that degree of px less than the degree of qx. Okay, it means that we already set, we, we already have step one, and we can jump into step two uh, in this number. Okay, next example. Here, degree of py is 2, yeah, because we have the highest the powers is 2. Uh, in degree of qy is we have 2 here plus 1. So the degree of qy is 2 plus 1. We have 3. So in, in this case, we already have that degree of py less than the degree of qy. It means that we we also have step 1 already set, and we can jump into step 2, yeah, in this example. What about this one? In number 3, uh, the degree of uh, px is 3, yeah, the highest power is 3, and this is qx, degree of qx is also 3. It means that we must divide them first. We do division. X cube of x divide x cube plus 3x squared x plus 2. That means we do this ordinary division, as we know from the junior high school. We multiply by 1. So this is x3 and this is plus x, yeah. So we subtract them. We have 3x squared so 2. So the px x cube, x cube plus 3x squared plus x plus 2 divided by 3 plus x. We'll have 1. S- Remainder is 3x squared plus 2 and divided by x cube plus x. So we must divide first, yeah, for the example 3. Okay, now we continue to solve one by one after we do uh, the checking of the degree of px and degree of qx. So in the number 1, we go to the step 2. We have that qx is x squared minus 1. And luckily, we have that this is quadrant non not defined uh, quadratic factors. So we have that we can factor out them become linear factors, x minus 1 and x plus 1. This is non repeating linear factors, yeah, non uh, repeating repeating linear. So we can use we can make the partial fraction of px and px dx. So it's minus 1. And this is uh, will be using case 1, yeah, case 1. Uh, in case 1, we have the denominator will be the factors of linear factors. So this is x minus 1. And this is must be x plus 1. And we- the, the constant, this constants. So we must determine it. How to determine it? We use the common denominator. Common denominator atau menyamakan penyebut means that we multiply the denominator. We have x minus 1, and this is x plus 1. We get the common denominator. So, uh, uh, if we use here, so A1 should be multiplied by x plus 1, yeah, because we get as if we can cancel out x plus 1. Yeah. So we get this one. And of course, A2 will be multiplied by uh, another factors from x plus 1, which is x minus 1. So this is the the uh, common denominator of linear algebra manipulation. This is one of algebra manipulation. Of course, after we have this equation. So as we look at the denominator, we have uh, same value, same value. So it means that for the numerator, we must also have the same value, same value. So we must have the same value. It means that we have that A1 uh, x plus 1 plus A2 x minus 1 is equal to 1. So, uh, uh, so we must solve, or we must find A1 and A2. And there are two uh, two way uh, to solve it. I I will I will give you detail about that. And you can choose what way or what the choice you like. Yeah, this is alternative one to solve this problem to find the value of A1 and A2. And also I will show you the alternative too. And you can choose the alternative you like. Okay, this one, uh, how to do that? We factor out, yeah, we factor out the the left uh, the left side. So we have A1, A1 x plus A1 and plus A2 x plus A2 is equal to 1. And then we we arrange we rearrange uh, become the terms of x. We have 1 plus A2 uh, multiplied by x plus, and the constant will be A1 plus A2. Oh, sorry. A1 minus, sorry. This is must be, okay, something minus A2, yeah. So this is minus A2. A1 minus A2. And this is what. Okay. The right, we have one set constant. Also, in the left we also have constant, but we have a factor in x. So actually, in the left we have one plus 0x, yeah, to equalize by with the left side. Uh, it means that A1 A1 minus A2 is equal to 1, and A1 plus A2 is equal to 0. Yeah. Because, implicitly, we have 0x in the right. Okay. To solve A1 and A2, we can use elimination and substitution. And this is we add them. We have 2A1. 2A1 is equal to 1. So we have that A1 is a half. And then after we have A1, so A2 will be minus a half. This is the uh, the alternative one to solve this equation. We have the alternative two, and this is the easiest way. Yeah? Maybe this is the favorite one to solve for the equation. How to solve this equation to find A1 and A2? By substitution, by substitute x into this equation. What kind of x can be substitute? Uh, it's depend on us. There is no obligation. You can choose anything you like. But the clue is you must choose to make us simple to find the solution A1 and A2. For example, in this equation, we can substitute x by 1, yeah, by 1. Why? Because if we substitute x by 1, so we have this equation will be 0. The second component will be 0. And instantly we have so this is 1 multiply by 2, yeah, because 1 by 1 plus 1. This is 0, and uh, the right uh, still 1 because uh, x uh, is not uh, is not contained in this. So we have A1. So after we get the A1, we can choose another x to get the 2. Uh, uh, we keep A1 uh, our, our information uh, as result information, our addition information. So maybe we can choose, for example, in this case, minus 1. Why? Because we have that if we substitute x by minus 1, the first component will be 0, and this is can be get easily. A2 can be determined easily. Uh, this is will be 0 plus A2 times minus 2 and is equal to 1. So A2 is equal to minus a half. Yeah, you can look at that. If you have more than two, A1, A2, A3, and so on, so maybe alternative two is easier to solve or to get is A2 and three and so on than the alternative one. So, but it's up to you, yeah. You can choose alternative one or you can use alternative two. Okay, after you get the uh, number or the value of A1. So you will have that 1 over x square minus 1 will be 1 will be replaced by a half divided by x minus 1 and the x2 will be replaced by minus 1 over 2 minus a half divided by x plus 1. So if you want to get the integral of 1 over x squared minus 1 dx, so you can replace this integrand by uh, 1 over 2x minus 1 and minus 1 over 2 uh, divided by x plus 1. So now, of course, so we can simplify this integral by pull out 1 over 2 from the integral. We have 1 over 2 integral dx divided by x minus 1 and minus yeah, you can pull out 1 over 2 also from the second integral. We have that dx divided by x plus 1. Yeah, so uh, we can continue the integral from the last. We have that uh, to the integral in the first integral will be natural logarithm of minus 1 minus 1 over 2 natural logarithm of x plus 1. And let's see. Yeah, you maybe know that in the uh, logarithm that division of logarithm, a logarithm of division can be subtraction of the numerator, the denominator. So we have the 1 over 2 natural logarithm of x minus 1 divided by x plus 1. So this is the solution of number 1 uh, in this example, integral of 1 over x square minus 1. Okay, let's we go to the second, yeah, to the second. This one x square y square minus 3y uh, minus 7. How to memorize it? I will try to in this slide because I have, have already uh, opened it this slide. Y square minus 3y minus 7. I hope I I You remember it? And this is 2y plus x, 2y plus, sorry, 2y plus 3, yeah. 2y plus 3, okay. This is uh, 2y plus 3 uh, multiplied by square of y plus 1 dy. I hope this is correct. Uh, I check it again. Okay, yeah, it's correct, yeah. Okay, let's we solve this one. We did it well before. The degree of px, degree of py, uh, already less than degree of qy. So we identify qx and also the qx, sorry, qy have the 2y plus 3 different non-repeating linear factors, and we have this one repeating linear factors y plus 1 square. Yeah. So this is not quadratic, yeah, not it is not quadratic, but repeating linear factors. So we can decide it. We will have case two, yeah, case two combined with the case one in the first factors. So from case two, say that px and qx, in this case py and qy, uy square minus 2y minus 7 divided by 2y plus 3 multiplied by square of y plus 1 square, y plus 1 will be here. Uh, this is for the different non-repeating 2y plus 3, and this is for the repeating. For the repeating denominator, we know that the denominator will be y plus 1, the this one, the this is the increasing of the powers. We will have that y plus 1 square. Yeah, we only have of 2, so the components, we will have 3 components, yeah, for the non-repeating and for the repeating, 2 times. So this is the all of them are linear, so the numerator should be constant, all of them. We can give the any symbol, not A1, A2, A3, or P1, P2. As we like, we can choose maybe A, B, C, simplified by A, B, C. Okay, once we solve them, and it's the details in the number one. In the next step is we do the common denominator, yeah, as we did before. The common denominator say that we must have 2y plus 3 here, and we choose the biggest denominators, y plus 1 square. Yeah, we don't need to write y plus 1 again here. We just need we just write the biggest power of denominator. Okay, let's 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 get the multiplication of the coefficient in the numerator. For A, uh, they must be multiplied by y plus 1 square, yeah, because the idea is we can cancel out y plus 1 square, and we have the original, we have the previous components. And also for b, we must, because b have the denominator square here, so we must multiply by 2y plus 3. Yeah, the idea also uh, cancel out them. We have the component 2. And for C, for C, because C did denominator of C y plus 1, so C must be multiplied by 2y plus 3 and by 1 of y plus 1. Yeah. s- If we cancel out there, we have the original components, the previous component. So this is the equation we have. And also the ideas to equalize the both of side, to equalize both of side, we have that the numerator must be same uh, both side, yeah, uh, left and right. So we have we must solve this equation a multiplied by y plus 1 square plus b multiplied by 2y plus 3 and plus c multiplied by 2y plus 3 multiplied by y plus 1. And this is will be the same with the y square minus 3y minus 7. Yeah, as we did it before, also here we can choose y, or at least we choose three y's, three value of y's, such that we can have the value of a, b, and c. Yeah, as I told you before, you can choose y such that you have the simple, simple equation to solve A, B, and C. In this case, I suggest you to choose y is equal to minus 1. Uh, it makes that uh, by this substitution, component 1 will be 0, also uh, component 3 will be 0. So we will have 0 plus, this is 2 times 1 plus 3 become 5. So 5b, and this is 0. And this is 1 minus what we have, minus 3 minus 7. We will have minus 9, isn't it? Minus 9. Yeah. Oh, it's correct. So we have that b become minus 9 over, yeah, 9 is correct. Now what else? So yeah, we can choose minus minus 3, what we have, minus 3 over 2, yeah, for example, to make this is will be 0 0, and so y will be it will be to get instantly. But uh, deal with the division, it's difficult to solve, so I avoid it to use y is minus 3 over 2, so I choose y is equal to 0. Yeah, this is also simple, and we have that Uh, 0 here will be A, yeah? A. Uh, s- B already have as minus 9 over 5. And this is will be 3, yeah? Because it is 0 plus then we have 3 plus 1, 3 times 1 will be 3, 3 C, and the right side, side will be minus 7. Uh, so uh, we, we will have plus, 3 C will be minus 7, minus 7. This is minus plus what we have plus 77 27 divide by 5, yeah, 27 divide by 5, so divide by 5, so we will have uh, uh, 35, yeah, 55 5 times 7 55, so we have minus divide by. Okay, let's we go to the next. Yeah, we need one more y. One more y. So I choose y is equal to 1, and this is will be for a, and this is still uh, minus 9 over 5 divide by choose 1 will be 5, yeah. And plus this is 5 times 2 will be 10, 10 C, and this is equal to 1 minus, so minus, oh, sorry. Okay, I have a problem here. Uh, minus 1 will be here, will be what we have here. Uh, 1, 1 minus uh, minus will be plus 3 minus 7. So we will have minus 3, isn't it? Yeah, minus 3, not minus 9. Yeah. So this is minus 3. Okay, I have a problem here. Minus 3. And also this one will be minus 3. Minus 3. And of course, this is must be replaced by minus 3, and we will have that uh, 9, 9 over 5, uh, 9 over 5 plus 9 over 5, 9 over 5, what we have here, 9 over 5, uh, what we have, 9 over 5, so 35, 24, minus, minus 26, yeah. Minus 26 over 5. Isn't it? Okay. Then this is also minus 3 over 5. Yeah. And then this is 1. 1 will be minus 9. And we have for A, for A, uh, plus 10 C, we will have uh, minus 9 plus 3. Plus 3, we have minus 6. Hmm. I hope I don't make a mistake. Uh, I do not make a mistake. 0, okay, 3, B is minus minus 3 over 5, 1 minus 1 plus 3 minus 7 minus 3 over 5. Yeah, okay. I hope all of them are correct. Yeah. Yeah. Okay. So we have that we must solve A A plus 3C is equal to minus 26 divided by 5. And this is for A plus 10C is equal to minus 6. Yeah, I hope it is correct. Yeah. Okay, how to do that? Yeah, we can multiply by 4. In the first, we have for A plus 12 C is equal to what we have here, 4 times 4 times 20, 26 will be minus 104 plus 5, isn't it? Then this is for A, 10 C, this is minus 6. And we uh, subtract them. Subtract them, we have uh, 2C is equal to, I, I don't, yeah, uh, mm, 0, 0, 0 here. B is minus 1, 0, 0, minus 1. Ah, sorry again. We have not 5 here, minus, we have the B here, B, so we have 3 here, minus 3, isn't it? So this is only minus 3 here, minus 3. And this is will be uh, we have 2. Yeah. We have 2, not to be picked up. So here, okay, I make. And then this is also minus 3. And then we have 6. Okay, oh, not, there is no any mistake. Okay. Let's we solve it, and it is more easy. We do it in the in the next slide, and this is will be will be more this is because we multiply by 4. This is still 6, so we have to C become 2 and C become 1. Yeah. And C become 1. Uh, we can replace by C 1 here. So uh, A plus 2 plus A plus uh, 0, yeah, 0, 3C. Okay, 3C. Yeah, so uh, replace C by 1 here. We have uh, minus 4 and A will be minus 1. Yeah. Okay, we replace A minus 1, B by minus 3, and C by 1. So uh, our equation y squared minus 3y minus 7 divided by uh, y 2y plus 3 multiplied by y plus 1 square. We will have that a minus 1 2y plus 3 plus b minus 3, is it? Uh, this is y plus 1 square and c will be 1. Yeah. Uh, y plus 1. Yeah. So this is a minus 1. Oh, yes. B minus 3 here and C is 1. Okay. Uh, we have the integral of y squared minus 2y minus 7 divided by 2y plus 3, and this is y plus 1 square dy. So we have the integral of three components minus 1 divided by 2y plus 3 plus minus 3 divided by y plus 1 square and plus 1 uh, over 1 plus 1 and dy. So we have three, there are three integrals. And this is minus dy plus 2y plus 3. And for the second, we will have minus 3. We'll pull out minus 3 from the integral. We have the dy y plus 1 square, y plus 1 square. And the last, we have that the uh, y plus 1. And we already know all of the integrals. Yeah, maybe we do little substitution. Here we do little substitution dy plus 3. And this is also the substitution y plus 1. Yeah, or maybe you can choose another symbol of substitution. This is also uh, y is w is y plus 1. So the integral will be a half because there are coefficient 2 in the front of y. So we have minus a half natural logarithm of 2y plus 3 and minus 3 natural logarithm of y plus 1. And the third, we have natural logarithm of y plus 1. And the uh, sorry, this is not natural logarithm. This is minus 1 over y plus 1. This is 3 and minus 1 over y plus 1. So we have the last the last answer, a half natural logarithm 2y plus 3, and this is plus 3 divided by y plus 1. that we have 1 plus 1 plus C. Okay, this is the solution as example of 2y plus 2, uh, 2y plus 3, and the, sorry, the example of number 2, yeah. Okay, let's we go to the example number 3. Yeah, as we know from the previous, this is our our last division, and now we concentrate, we focus on this equation uh, to get the integral of this equation, because the first equation is easier, easier than the second. So we focus on the second components. Okay, the second component said that 3x. Sorry, I must remember it. 3x squared plus 2 divided by x cube plus x. So this is the number 3. We focus on 3x squared plus 2 divided by x cube plus x. Um, in this case, px as 3x squared plus 2, and the qx as x cube plus x. So we can look at the qx will be x cube plus x, and the composition or the factor of qx will be x multiplied by x squared plus 1. We have, this is linear factors, and this is definite quadratic factors, because we cannot uh, put the factor for these factors, yeah. So the partial fraction will be px divided by qx uh, will be case in this is case 3, yeah, case 3, because we have non-repeating quadratic factors. So we have linears, and also we have um, quadratic. So in this case, x squared plus x1. If we have denominator linear factors, so the numerator must be constant. Uh, for the quadratic factors, we must linear. So this is dx plus c. Now the business still continue uh, to find the value of a, b, and c. In this case, as we did in the previous example, we do common denominator again, x squared plus 1. So a must be multiplied with x squared plus 1. Uh, px dx plus c must be multiplied by x, isn't it? Because if we cancel out, we get the previous components. Okay, so on the other hand, px divided by qx, as we know, is 3 x squared plus 2 divided by x cubed plus x. So we must have it multiplied by x squared plus 1 uh, is bx plus c multiplied by x uh, is equal to 3x squared plus 2. And we know before we can choose some x to find A, B, and C. Yeah, at least we choose x 3x here to substitute in this equation. Mm. Yeah, I suggest you to choose x is equal to 0, yeah, because it makes the second component will be 0. And this is will be A, 0 plus 1 still 1. So it's 0 is equal to 2. So instantly we have A is equal to 2. Yeah, I hope I check it again. For number 3, we have 3x squared plus 2. Yeah, okay. It's correct. Uh, then we we substitute another value of x. In this case, x, yeah, maybe 1, for example. Uh, Here we have to A, 2. So 2 times 2, is- this is 1. So we have B plus C multiplied by 1. And then this is will be 5. Yeah. So we have the equation B plus C is equal to 1. 5 plus 4. And then maybe we can substitute x by minus 1. So this is still the same in the previous. We have that 2 times 2, and this is minus b, c. This is minus 1. So in the right, still the same. We have 5. So minus minus become become plus. We have b minus c is equal to 5. If we perform b and c using elimination substitution, this is elimination. We have to b is equal to 6 and b equal to 3. And b is 3, c will be minus 2. So, we divide by cube of the x between is 2, 2 over x is b is 3, 3x c is minus 2. Minus 2 divided by x cube of x. I hope I don't make a mistake again. 0 here, we have 1. To x by 1, we have 2. X n is 2, so we have 4. This is 1, b and plus c and 5 here. So b plus c is equal to 1. Okay. Yeah, I think it is correct. Yeah. Next. Oh, sorry. It should be square, not cube here. Here. Uh, X square plus 1. Yeah. Okay, after we get it, so the integral can be replaced by the integral of 3x squared plus 2 divided by x cubed plus x with dx. It become, we have two components, 2 divided by x plus what we have. This is 3x minus 2. 3x 3x minus 2 divided by x square plus 1 dx. So we have two integrals, integrals of dx divided by x plus the integral of 3x plus minus 2 minus 2 uh, 3x minus 2 3x minus 2 divided by x squared plus 1 dx. Yeah. So still have some problem here. Maybe we can replace, we can spread this. The first one is okay. Yeah, it's not a problem because we know that this is a natural logarithm of x. So, but we still write it in place. We divide it into to 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 integrals 3 x dx divided by x squared plus 1 and plus minus 2 uh, integral of dx x squared plus 1. These integrals, we already have the integral from the, this is tangent, tangent x, yeah. But here we use a little substitution. U is equal to x squared plus 1. The u is equal to the x 2x dx. So x dx is half of du. So we have 2. This is will be natural logarithm of x. This is will be uh, 3 over 2 natural logarithm of x squared plus 1. In the last, we will have 2 tangent x c. So this is the integral to the 3x squared plus plus 2. So this is not the end of the tree. We must make a conclusion. The our integral should be like this. Number 3, our integral should be uh, cube plus 3x squared plus x plus 2 divided by x cube plus x dx become integral of 1 plus 3x square plus 2 divided by x cube plus x dx. So the integral of dx is integral of 3x square plus 2 divided by x cube plus x dx. Then this is easy. Yes, and this integral had been done in the last slide. Two natural logarithm of x plus, plus or minus plus, yes, plus 3 over 2 uh, 3 over 2 3 over 2 uh, natural logarithm square plus 1, then minus 2 minus minus 2 uh, tangent x plus c. So this is the last answer of number 3. Okay. Uh, you can look at the solution of this technique, a partial fraction, is quite long, quite long. You can look at that. There are some steps to solve the problem. So I suggest you to make it detailed and write it again in your paper. The solution, what we have in this presentation. So make it become your own notes. Yeah. Uh, Read it again. Uh, I will give you this slides, the scribble scribed slides, but I hope you write down by yourself. Make it detail from the beginning uh, up to the end of the solution to make it clear for you. Yeah, this is sample one, example two, and three in the example one, 9.2. Please do it as I ask you. Okay, after you make it detailed and write down by yourself the solution of number one, two, and three. You can continue the solution of this exercise. The solution of this exercise, uh, I can solve it for you because we have a limitation of time to solve it one by one. I give you the clue how to solve this problem. And please continue it uh, by yourself. Number one. Number one, the clue is substitution to make irrational become rational. So the substitution is power uh, uh, is minus 3 to the power of 1 over 3. Yeah, this is the substitution of uh, take of 3 the equation, both of side, we have u cube is equal to x minus 3. And do the rest as I did in the previous example. Here, uh, we have two components involving irrational. So we choose the lowest power. So u is 4 4 root of x. So x power of 1 over 4. And of course, we have u4 uh, is equal to x, or u square is equal to x 1 uh, power of a half. So this is the substitution uh, for substitution of number two. And number three, the clue is we can factor factor out these polynomials qx this is x plus 2 uh, x plus 3. So then we have case 1 here. Case 1, the non-repeating linear vectors. And px and kx uh, will be to partial fraction. Yeah. Number four, we already have the linear factors for qx here. So it is easy to say that this is also in case one. So the factor will be x a plus, this is x plus 1 will be b, and this is x minus 2 uh, c. And again, please find the value of a, b, and c. Now, for number 5, we already have the qx. This is x multiplied by x plus 1 square. So this is non-repeating, but this is repeating. So we can look at this is can be in the case 2. So 1 over x plus 1 square, we have that the partial fraction will be x plus this is will be x plus 1 square, and plus the third is x plus 1. Yeah, because we linear repeating linear factors are 2 times. So this is a, b, and c. And number six, we have that the degree, oh yeah, from 3, 4, and 5, the degree of px less than the degree of qx. Also, for the number 6, the degree of px is 2, and the degree of qx is 3. So, degree of px less than the degree of qx. And then the partial fraction of Px and Qx in this case, for the number 6, we have that this is quadratic, yeah, definite definite quadratic factors. So x squared plus x here, plus 1 here, plus 1 plus this is the linear factors x minus 1. So we have the numerator must be linear here, ax plus b, and the linear the numerator must be constant c. And again, please find the value of a, b, and c. And what about number 7? Number 7, we must divide because the degree of px greater than the degree of qx. So we must divide y cube plus y square, divide y 4 plus 1 power of 4, y power of 4 plus 1. So multiply by y, we have y power of 4 uh, plus y cube, divide it, subtract it, we have minus y cube plus plus 1, and this is must be multiplied by minus 1. This is minus 1 cube minus y cube, and subtract them, we have we have the I square plus 1. So uh, y power of 4 plus 1 divided by y cube plus y square, will have y minus 1, and the remainder is y square plus 1 divided by uh, y cube plus y square. Okay, Yeah, this is the clue. You can continue the rest of the solution of number seven. Yeah, please do it by yourself. Yeah, if you have some difficulties to solve it, you can ask your assistant, or the assistant cannot or cannot help you. You can ask me. Okay, that's all the presentation of meeting 9 in this evening, and I hope you can read it, and you can uh, write down by yourself in your notes. This presentation will be uploaded to the YouTube, and I will send you the link of that's YouTube. For the registration of this meeting will be open uh, in the next day, in the Tuesday. I will inform you whether the registration is can be accessible or not. I will inform you later. Okay. Thank you very much, Cherry, Aaron, and
Thank you,
Treasulia,
sir.
and have a nice rest today. And thank you very much.
Yeah. Thank you, sir.
Yeah, thank you, sir.